Hey everyone, and welcome to the deep dive. Today we're getting really small. Like small as in, we're talking nanometers here. The world of gold, nanoparticles.
Smaller than you can even imagine.
Smaller than you can even imagine, right? Our listener wants to know how these tiny particles react to light to generate pressure waves in fluids.
Sounds complicated, but it's really pretty cool once you get it.
So they sent over a bunch of research, including this recent paper on the photoacoustic response of gold nanoparticles.
Especially those with a silica shell.
Right, exactly, those silica-coated ones.
Those are really interesting.
So we're going to dig into all that today to see what makes these pressure waves and why they're so important.
You ready to get small?
Let's do it.
God.
So gold, at this nanoscale, it's like a completely different material, right?
Totally.
Think about shining a light on a gold necklace. Nothing really happens, right?
Yep.
But shrink that gold down to the nanoscale,
Now things get interesting.
and that's where it gets really wild, because at that size, gold becomes amazingly good at absorbing light.
Like it turns into a tiny little antenna.
And that absorbed light, it doesn't just disappear, it turns into a lot of heat, and really quickly, too. All that energy super concentrated.
Imagine the possibilities.
Okay, so now let's say this nanoparticle is inside the body surrounded by fluids. What happens when all that intense heat hits the water in our cells?
Tiny explosions, not like big booms or anything.
Well, what happens?
That heat makes the water vaporize super fast and creates a vapor nanobubble.
A nanobubble.
And that bubble, it collapses almost immediately, and boom, you've got a pressure wave. That's wild. So you're telling me shining a light on these nanoparticles can create actual pressure waves inside something?
Exactly. And we can control those waves too. But we'll get to that.
Okay, so speaking of controlling things, our listener was really interested in those gold nanoparticles with the silica shell. They said adding silica, basically glass, makes them better at transferring heat. I don't get it.
It seems counterintuitive, right? Like you're adding an insulator. Shouldn't that make it harder to transfer heat?
Yeah, exactly.
It's all about these things called electron-phonon interactions happening between the gold and that silica shell.
Electron-phonon interactions.
Now stay with me here. It's like a relay race where the gold electrons are carrying the heat energy and they need to pass it off to the water molecules. The silica shell, it's like a middleman that makes that handoff smoother. So the silica actually helps the gold pass the heat to the water more efficiently.
You got it. And that means we can control how intense that pressure wave is just by changing the silica shell. It's like a volume knob for these nanoscale explosions.
That's incredible. What are some of the ways we can use this? So we're talking about controlling pressure waves at like the nanoscale level. That's going to have some crazy applications, right?
Oh, absolutely. This level of control, it opens up a ton of possibilities, especially in biomedicine.
Okay, so like what could we actually do with this?
Well, think about targeting and destroying cancer cells, like with incredible precision.
Right.
Way less damage to healthy tissue.
So more effective treatments, fewer side effects, that's huge.
Exactly, and that's just one example.
Wow, what else? What else could we do?
We could use these pressure waves to deliver drugs, think like directly to specific cells deep inside the body.
So it's like these pressure waves are acting like little tiny delivery trucks.
That's a good way to put it. They could create these little temporary openings in cell membranes to get the drugs right where they need to go.
That's incredible. So we're talking about treating diseases at a cellular level with basically no invasiveness.
It's pretty amazing stuff. And that's just in biomedicine.
Right. You mentioned manipulating materials earlier. What did you mean by that?
We can use these pressure waves to actually build things at the nanoscale.
Build things? Like what?
New materials. Imagine putting together atoms like Legos. That kind of precision.
You're blowing my mind here. So you're saying we could revolutionize electronics, manufacturing, even energy production, all by manipulating things at the nanoscale.
Exactly, and it all comes back to those pressure waves generated by shining light on these tiny gold nanoparticles.
It's wild to think something so small could have such a huge impact.
It really is. And the best part is we're only just getting started.
So what's next for this technology? Where do we even go from here?
That's the exciting part. We're really just scratching the surface here. There are so many avenues to explore.
Like what? Give me an example.
Well, researchers are looking into using these pressure waves to trigger specific chemical reactions.
Wow.
Or even controlling heat flow at incredibly small scale.
It's like we've got this whole new toolkit for manipulating the world around us.
And it's all thanks to these incredible little nanoparticles.
It's like we're discovering a whole new universe. But instead of stars and planets, it's all these tiny particles with amazing abilities.
That's a great way to put it. And Just like exploring space, understanding the nanoscale could lead to some groundbreaking discoveries.
But with all this talk about manipulating cells and building new materials from the atom up, are there any limits to this technology, or is it like we have unlimited power at the nanoscale now?
Well, we don't have unlimited power just yet, but researchers are pushing the boundaries all the time. One really interesting area is using these pressure waves to control individual molecules.
Whoa, hold on. So you're saying we could actually build things with molecules, like with nanoscale Legos?
You got it.
Yeah.
Imagine building complex molecules with that level of precision. It could totally change fields like materials, science, maybe even computing.
It's mind-blowing to think we could be building things at such a small scale. We started with gold nanoparticles absorbing light, and now we're talking about potentially building new materials and technologies atom by atom. It really highlights how important it is to keep exploring the world at the nanoscale.
Absolutely. And it just goes to show that even the smallest discoveries can have a huge impact.
So much potential still out there waiting to be uncovered.
Exactly. And as we keep learning more about these gold nanoparticles and the crazy things they can do, who knows what other breakthroughs are just around the corner?
It's really exciting stuff. Well, that wraps up our deep dive into the world of gold nanoparticles and their explosive potential. We learned that something as small as a gold nanoparticle can absorb light, convert it to heat, and generate pressure waves. And those pressure waves, they have the potential to change medicine manufacturing and so much more. Thanks for joining us today and keep exploring the wonders of science.